Okay, here we go. Lesson number 2, parallel circuits. I'm going to talk about resistance in this second lesson. All right, so we already know a couple from the first episode that the voltage across each branch is the same. All right, so we can say then in this case we're going to use a 12 volt battery source, and across each branch and each resistor here we will have that same voltage, right? So over here E2 equals 12 volts across there. In this example, we are going to give some resistive values. R1 we're going to call 3 ohms. R2 we're going to call 6 ohms. All right, what we're going to be looking for is what is RT going to be, all right, based on those values. Okay, so a couple things to kind of keep in mind while we do this. All right, let's see, characteristics in Ohm's law are the relationship between voltage, current, and resistance. Okay, so remember what we're talking about here is voltage is constant. Okay, in this example, right? ET equals E1 equals E2, and we actually gave this a value of 12 volts. Okay. What we're doing in this case here is we're looking at the IT, okay, and it increases with every branch that we add. All right, so if we had more than these 2 branches, it'd be the sum of all the branches for our total current. Okay, so we know that the relationship between the current flow and the voltage is that if the current is going to increase, our resistance will be lower, okay, for a voltage that is the same. Okay, so keep that in mind as we solve for what our RT is. All right, and as we add branches into the circuit, or as we add more paths for current to flow, our current is going to increase, and then our resistance is going to decrease. All right, so that's going to be explained in this example. So before we get to that, okay, let's solve for the individual current flows in each branch using Ohm's law. So I1 we will solve here, I2 over here, and we use simple Ohm's law using the values from the same part of the circuit. 12 divided by 3 ohms for R1, and we got a current flow of 4 amps through there. And I2 is going to be E2 divided by R2. 12 volts again, because that's the characteristic of a parallel circuit. 6 ohms is the value there, so we have a current flow of 2 amps flowing through I2. Okay, we can then determine what our IT is by adding up the sum of the current in the 2 branches, and we have a 6 amp current flow through there. Okay, so let's use Ohm's law to solve for RT and see what we come up with. Okay, RT using ET divided by IT, we got 12 volts divided by 6 amps is going to give us a current flow of, a resistance of 2 ohms. Okay, so first thing I want you to take a look at is the value of that 2 ohms and compare it to the resistance values of the other 2 resistive values in the circuit. It is lower than either one of those. Okay, so that's the rule for resistance. So we're going to put that in here. Okay, all right, is lower than any branch resistive value. Okay, so any branch that you have, the R total is going to be lower than any individual resistive branch that you have in that circuit. Okay, so keep that in mind as we explain this further. Right, 2 ohms. Okay, so that's one way we can solve that in this circuit, is by using the Ohm's law, given what the values that we had, the resistance and the voltage was given. Okay, so let's take a look at those 2 values. Okay, in this circuit, let's just kind of redraw that again. Throw a couple resistors in here. Put the nodes in. We had R1 was 3 ohms. R2 was 6 ohms. Is that right? Yep. Okay, and our RT we knew was 2 ohms. Okay, so there's a few ways that we can solve this with the 2 values. Okay, so it's the reciprocal method. All right, so as we add more branches onto here, all right, and we'd have an R3, for example. All right, we would add that in. All right, R2 would still go down. Okay, so as we add more branches, more current flow. As I goes up, our resistance is going to go down. Okay, so keep that in mind as we continue to go through a couple of these examples here. Let's use the whoops. Okay, let's get back on track here. All right, 2 ohms. Okay, so let's take a look at a couple ways that we can solve that. Okay, the first common way is using the reciprocal method. All right, and because we get some pretty easy numbers to work with here, I can do this by showing you every step of the way. What you're going to want to do is be able to punch the calculator properly, all right, and efficiently by using the 1/x button or to the -1 button on your calculator, and getting to know how to use that. Okay, it's much simpler, but I'll give you the concepts here with the reciprocal method. All right, so 1/RT, and we plug in the values. 1/6. What we have to do is find a common denominator, which is going to be 6. So we'd have 2/6 plus 1/6, and then 1/RT is going to equal 3/6. All right, we flip those around, so it's RT over 1 equals 6/3. RT divided by 1 is RT. 6 divided by 3 is 2 ohms. And there we got our 2 ohms. Okay. As we would add another one, you could do the same steps, find a common denominator, or as I said, learn to plug in with your calculator using reciprocals. You're looking for the x to the -1 button or the 1/x button, and finding the reciprocal value of that. Okay, we'll do some of those examples in class. Okay. When you have 2 resistors, there is a pretty common way of doing this without the common denominator. These were pretty easy numbers to work with, but there is also for 2 resistors, you can use what's called the product over sum method. Okay, where the formula for that is going to be R1 times R2 over R1 plus R2. Product of the 2 divided by the sum of the 2. Okay, remember, if you do this in a calculator, you're going to have to throw brackets around those 2, right? Otherwise, you're going to divide by R1 only and then add on R2 separately, right? So not necessarily necessary with me writing it out like this, but if you punch into a calculator and do this in one formula, you got to throw those brackets around that addition part, so it does that separately, and so you divide the product by the sum. Okay, so anyway, let's plug in these numbers here. We've got R1 is 3 times 6 divided by 3 plus 6. And you'd have 18 divided by 9, and lo and behold, we've got 2 ohms, right? So that is another method you can do when you have just 2 resistors using the product over sum method, as opposed to what you'll have over here is called the reciprocal method. Okay, and like I said, there's a pretty good chapter in your textbook or page on your textbook that shows you how to plug in those values into your calculator. Okay, very important that we practice some of those. Okay, there's another common method that we can do. Let's add another page here. Okay, and that is if you have resistors of the same values. Okay, so this is going to be for all resistors of the same value. Okay, this is the only way this will work. Okay, so let's do 3 branches for this one. Okay, let's say they're all 6 ohms. Okay, I want to find RT. Okay, so this one's pretty simple. It's the formula is RT is the R of one resistor divided by N, which is the number of branches or resistors that you have of that same value, right? So here we have 6 because that's the individual resistor. They're all the same. I've got 3 branches. The value here would also be 2 ohms, okay, for this example, because I have 3 branches, all of 6 ohms, okay. That's just an extension of the reciprocal method of 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3 oops. We already got a common denominator. I'm rushing through this. Plugging in some wrong numbers here. Okay, so we've got 3 over 6, so we don't have to find a common denominator. It's already there. Flip that formula. 3, which incidentally is what we had over there, and 2 ohms. Okay, so it's just a variation of that formula, right? Just kind of skips a couple steps because we have a common denominator already with the same value of each resistor. Okay, so those are the 3 common methods of doing it. All right, the reciprocal method is kind of your default method, right? As current increases in the circuit, right, our resistance is actually decreasing because we are adding more paths for current flow in our circuit, and our voltage remain constant across each branch. Okay, so that is the resistive method. Okay, I cannot stress enough how important it is to learn how to do that on your calculator so that you can solve for all the values, for the resistive values, if you're not given voltage and current. Let's say you have to solve for your RT only by using the resistive values. Okay, and remember this rule: All right, RT is always lower than the lowest resistive value you have in any branch. Right, so our 2 ohms is lower than our lowest of 3 ohms that was in the first branch.